Welcome to Math with Malia. Today we're doing Savvas enVision Algebra 1, Topic 2, Lesson 3, Standard Form for Linear Equations. We learned about slope-intercept form, we learned about point-slope form, and now we're going to look at standard form and when this form of linear equations is useful. For the explore and reason, we have this equation, x plus 2y equals 5, and the ordered pair -1, 3 is a solution. Because if we plugged in -1 and -3 into that equation, -1 plus 2 times 3, -1 plus 6 does equal 5. So it makes the equation true. So let's fill in some more of these tables. If we plug in x for 3, so then that means we'd have +3 plus 2y equals 5. We need to subtract 3 from both sides. So we'd have 2y equals 2. That means y would equal 1. Now we'll plug in 7 for x. X equals 7. That means we're going to subtract 7 from both sides. We end up with -2. -2 divided by 2 is -1. If we plug in 11, +11, that means we're going to subtract 11 from both sides. So then we have -6. -6 divided by 2 is -3. And now we have any value. Any value. Let's pick 12. If I plug in 12, since I'm increasing, if I plug in 12, I'm going to subtract 12 from both sides. I end up with -7. -7 divided by 2 is -3.5. So now let's see if we can plot these on our coordinate plane. It's going to be very small, but we can do it. So -1, 3, 3, 1, 7, 1, 2, 3, 4, 5, 6, 7, -1. Oh, I didn't go over enough. More. 11 is off the grid, so that's fine. We've got these points. We could connect with our straight edge, and I get to adjust it. Wonders of technology. And then add my arrows. So there's the line for that equation. Any 2 points on this line would be a solution. So I could say this point up here would fit. Okay, any point on that line would make this equation true. So here is an equation in standard form. Standard form is when we have this form. We have both the x and the y variables on the left and the constant is on the right side. So we represent it like this. A times x plus b times y equals c for constant. Capital A is the coefficient in front of the x variable, capital B is the coefficient in front of y, and capital C represents the constant. So that's standard form. When we have an equation in standard form, we can use our x and y intercepts to graph. So remember, what is an x-intercept? An x-intercept is when y equals 0. And a y-intercept is when x equals 0. So we're just going to plug that in. For the x-intercept, it's when y equals 0. So instead of y, I'm going to substitute 0. That means the y term just gets canceled out. It goes away. So I have 3x equals 9. Divide by the coefficient, x equals 3. So my x-intercept is when x equals 3. So I can plot that point, x equals 3. Do the same thing for the y-intercept. Y-intercept is when x equals 0. So substitute 0 in for x. Again, that x term's just going to go away. -2y equals 9. Divide both sides by -2. You get y equals -4.5. So the y-intercept is there at -4.5. We have 2 points. Anytime we have 2 points on a coordinate plane, we can connect them and make a line if it's linear. So then use your straight edge and connect those 2 points. So let's sketch this graph. 4x plus 5y equals 10. It's in standard form, so we're going to use our intercepts. When x equals 0 and when y equals 0. Okay, so when x equals 0, 4 times 0 plus 5y equals 10. My x term goes away. I have 5y equals 10, y equals 2. Divide both sides by the coefficient. That's how we got there. Okay, now when y equals 0, substitute 0 for y into my equation. Again, my x term is my y term is going to go away now. I have 4x equals 10. Divide both sides by the coefficient. X equals 5/2. And I can plot those. So I can plot my y-intercept, y equals 2, and my x-intercept is at 2.5. There's my 2 points. Connect them with my straight edge. Make sure your line actually goes through the points. Add arrows. There's your line. Understanding standard form, here's an application problem. Hannah will spend $150 on music festival tickets. So that's her budget. Reserved seats cost $25 and general admission tickets cost $10. So I have two different rates. I have a rate for reserved seats and I have a rate for general admission tickets where you just go and find a seat. We can represent this using standard form. When we have two different rates, we can use our standard form because I have my x variable has a coefficient. There's one rate for my x variable and my y variable has a coefficient, or my y variable has a rate. So here we're defining the variables. We're saying x is the reserved seat. So the rate for reserved seat is 25. So I can represent that with the expression 25x. And I'm defining the y variable to be general admission tickets. The rate for general admission tickets is 10, so I can use the expression 10y. The cost of all of the reserved seats, 25x, plus the cost of all of the general admission tickets, 10y, equals her budget. So I have a limit or I have a constraint. This is why standard form can be useful. Again, I have two different rates for two different variables, and I have a budget or a limit. It's also called a constraint. You can see that we can also rearrange this equation using algebra. We can turn this into slope-intercept form. So slope-intercept form, remember, is y equals mx plus b. I need to get the y variable isolated. I need to solve for y. So the first thing I need to do is move the x term to the other side. I do that by doing the opposite operation. So I subtract 25x from both sides. Now I can't subtract 25x from a constant, so it's just going to be set aside. And knowing y-intercept or knowing slope-intercept form that the x term comes before the constant term, I'm just going to push it in front. So here's my negative 25x because I moved it from the opposite side. It becomes negative, and my constant is still there. Again, don't forget, don't accidentally subtract 25 from 150. They're not like terms. And then we need to divide by the coefficient of our y term. So divide everything by 10. When you divide one thing by 10, you have to divide everything in the equation by the same thing. That's the property of equality. So then we get our equation in slope-intercept form. So now we can identify an initial value and a rate, a unit rate. So comparing the two, what information do we know? Well, again, we know the initial value, or that she can buy 15 general admission tickets if she has no reserved tickets. Or if it's in standard form, we know her budget. We know the constraint, the total amount of money she can spend. Which equation from part B would you use to find the x-intercept of the graph? Well, remember, whenever we're using intercepts, we're going to be looking at standard form. Okay, ax plus by equals c. So if it's in standard form, then we can just find the x-intercept. That's when y equals 0, and we would plug in y for 0, and we would solve for the x-intercept. Example 3, graphing from standard form. When a equals 0, or when the coefficient for x is 0. So what does that look like? Well, if the coefficient for x is 0, that term goes away. I just have 2y equals 6. Dividing by the coefficient, I have y equals 3. What does this say? This says y always is 3. No matter what x equals, y will always be 3. So we're going to get this horizontal line. Think about it. Any value for x, no matter what x is, y will equal 3. No matter what x is, y will always equal 3. So I'm going to get this horizontal line where every y value is 3. And if it's in slope-intercept form, I'm going to turn it into slope-intercept form, equals 0x, because negative 0 is the same thing, plus 6, divide by 2, divide by 2, divide by 2, y equals 0x plus 3. Again, there's my y equals 3. What's my slope? What's the value of m? M is 0. So my slope is 0. I'm not going up or down. You can see it's just a flat line. What about if the coefficient for y equals 0? What if capital B equals 0? So again, plug in 0 for b. The y term goes away. Now I have 3x equals negative 6. Divide both sides by the coefficient. I have x equals negative 2. Again, what does this say? X is always negative 2. No matter what, x is always negative 2. No matter what value for y, x is negative 2. No matter what value for y, x will always be at negative 2. So now we have a vertical line. So you'll want to know these special cases for standard form, for vertical lines and horizontal lines, and what those equations would look like. Okay, let's graph a couple of these. 3y equals negative 18. Well, I need to isolate y, so I'm going to divide both sides by 3. I have y equals negative 6. Y always equals negative 6. So no matter what x is, y is going to be negative 6. 1, 2, 3, 4, 5, 6. No matter what, y is at negative 6. So you can even just plot a few points where y equals negative 6. And then I'm just going to use a highlighter. Connect those with a straight line and add your arrows. For the second one, 4x equals 12. Divide both sides by the coefficient. X equals 3. What does that say? X always equals 3. So no matter what, x will always equal 3. No matter what y value I have, x will equal 3. So we're going to have this vertical line at 3. Application. Tamira is making trail mix. She has $30 to spend. So we have a limit, we have a constraint, we have a budget. And she can buy a mixture of almonds and cashews, and she wants about the same of almonds as cashews. You can see we have two different rates. Again, we have a rate for almonds and we have a rate for cashews. Okay? So this is why we're going to use standard form. We have two different rates and we have a constraint or a budget. So we're going to say x is the price of almonds. So the rate of almonds is 10. So my expression for the total price of almonds is 10x. Plus the price of cashews. The rate of cashews is $12 per pound. Y is the pounds of cashews, 12y. Add those together, I get my budget of 30. So here's our standard form equation. And then finding the x and y intercepts. We can plug in value when y equals 0 and when x equals 0 and solve. I have an x-intercept at 3 and a y-intercept at 2.5. From there, we can graph our equation. So here's our graph with our intercepts at 2.5 and our x-intercept at 3, connecting those 2 points. Looking at our graph, we want to find where the values for x and the value for y is about the same. So if I'm looking at 1.5, it doesn't quite go up to 1.5, maybe a little bit less. So if I go to 1.4, it looks like it might be close to that, a little bit less than 1.5 for my y value. So let's choose an x value of 1.4 and plug it into our equation. So 10 times 1.4 plus 12y equals 30, and we're going to solve for y. So 14 plus 12y equals 30, 12y equals 16, y equals 1.33. That's pretty close to 1.4. So remember, the x value was how many pounds of almond, and the y value was pounds of cashews. Those are pretty close, so she can buy about 1.4 of each. Try it number 4. How does the equation change if Tamira spends $40 on almonds and cashews? So now her budget has changed. The rate for almonds is still 10x. The rate for cashews is still 12y, but now the constant is 40. So we're going to go through the same process. we're going to find our x-intercepts and our y-intercepts. So substitute 0 in for x. Y equals 3.33. Substitute y, 0 for y. X will equal 4. So there's my two intercepts. I have a point at x equals 4 and a point at 3.33, 1, 2, 3, and a third. Okay. I'm going to connect these. Okay, just a little adjusting. I want to make sure I'm going through. Come back. So where are the x values and the y values approximately the same? So if I'm looking at 2, it doesn't quite get to 2, so maybe a little bit less than 2 gets me a little bit less than 2 for both. So somewhere right there, a little bit less than 2. Let's guess, I don't know, 1.8. So let's plug in that. 10 times 1.8 equals 12, plus 12y equals 40. 18 plus 12y equals 40. 12y equals 22. Y equals 1.83. Pretty good. So she can buy about 1.8 pounds of each if her budget is 40. Here's the concept summary for standard form. So remember, standard form, ax plus by equals c. Both y variables and x variables are on the left and the constant is on the right. Okay. And we can rearrange it into slope-intercept form. We can find the y-intercept, but when we have it in standard form, we're going to use the intercepts, the x-intercepts and the y-intercepts. Just substitute 0 for x and solve. Substitute 0 for y and solve. You have your 2 points to graph. And we use standard form when we have two rates of two values of two quantities and when we have a constraint. We have a budget or a limit. This is when standard form can be used. Leave any questions you have in the comments and make sure and come back for lesson 4.